Hi folks, this is 21B on page 482. They give us the equations of two planes and they want us to find the angle between the planes. Okay, so what we had shown was that the angle between two planes is equivalent to the angle between their normal vectors. Okay, so first thing I have to do is just identify the normal vectors of these planes. So normal vector 1 is going to be 1, negative 1, negative 1. Just look at the A, B, and C. And then normal vector 2 is just going to be 2, 3, negative 1. And in order to determine the angle between two vectors, easiest thing is to use the dot product. Okay, so essentially we're going to use the fact that n1 dot n2 is equal to the magnitude of n1 times the magnitude of n2 times cosine of theta. Okay, so let's find n1 dot n2. Okay, so here we have 1 times 2 is 2 minus 3. And then this is just going to be plus 1. So plus 1 is equal to magnitude of n1, which is 1 plus 1 plus 1, just root 3. And here magnitude of n2, so 4 plus 9 is 13, plus 1 is 14, times cosine of theta. Okay, well, look at that. 2 minus 3 plus 1 is just equal to 0. Okay, so divide these, just divide this out the other side, it'll still be equal to 0, so you end up with cos theta is equal to 0, and of course we know that that occurs when theta is equal to 90 degrees. Okay, so there we go, we found our angle. In this case here, these two planes just happen to be perpendicular to each other. Okay, just recall when you're finding angles between planes that if you do get an answer that's greater than 90, so between 90 and 180, you do have to switch it over to the supplementary angle, because we assume that the angle should be acute, except in this one scenario where the two planes happen to be perpendicular. Okay, that's it for this one.